So once you complete a synthesis, now next step is to perform an implementation, right? Again, remember that specifying a constraint before proceeding to an implementation is mandatory, right? We'll just go ahead and click on run implementation. Now, depending on the constraint that we specify, our logic will be placed at the specific position in an FPGA, right? So after we perform an implementation, we'll be understanding where our logic is placed, right? So we are utilizing only a single LUT over here that you could see over here, right? So let us analyze out of all the LUTs that we have on our FPGA chip, which LUT we are utilizing for implementation of our logic. So our implementation is successful. We'll just go ahead and click on open implementation design, okay? And then we'll just be analyzing where exactly our logic is placed, right? Now, if you analyze the schematic, right? So if you go to an implementation design and again analyze the schematic, so you have exactly the same schematic, right? So the schematic that we have in a case of a synthesis and implementation remains same, okay? And this will be in most of the cases until and unless you add an implementation strategies, okay? So if you try to reduce the area, in that case some of the LUT will be trim, and then you'll be finding implementation schematic is different as compared to synthesis schematic. But if you do not apply any optimization strategy, in that case, okay, your implementation schematic as well as synthesis schematic will be almost identical, right? And that is what we are observing over here, right? And now when we go to a device, right? So if you analyze the place where we have utilized the place where we added our logic is this one, right? So this LUT is highlighted with a blue color, and you could clearly see the reason, because we are utilizing G15, right? So which is one of our output pin, right? And then the other pin that we have is over here, right? So this is, I guess, our next input. This D18 represent our output port, right? And G15 and P15 represent our input port, right? So we have G15 over here, right? Then output is at this position, right? And then last one is P15, which is over here, right? So depending on the constraint that you specify, the specific location will be chosen, okay? And here we have our LUT, okay? So this basically represent an AND gate that we are implementing, right? So now you understand the usage of an implementation, right? So this basically, now synthesis have converted our HDL code to the FPGA primitives, okay? And then when you specify a constraint, the specific location is identified where we will be adding our logic, right? So once you complete an implementation, now we'll go ahead and we reach to a last step, which is program and debug, okay? And here the first step is generate bitstream, right? So the rest of the option that you see in a synthesis and implementation we'll be discussing as we progress further, right? So if you just analyze the flow that we have in a flow navigator, so we completed a simulation, we completed an analysis, we completed a synthesis, and now we also completed an implementation, right? And we already discussed when we are working with an simulation, so you'll be finding this 4 options are disabled there, but now we completed synthesis and an implementation, right? And due to this you could find out that all of these 4 options are enabled, right? And this also makes sense because we have an HDL code where we perform a behavioral verification, but when we perform a synthesis, our HDL code is transformed to a primitives, right? So it becomes mandatory that we verify whether our design is still working as expected, right? Similarly, when we consider an implementation, right now when we are having a simple design without an optimization strategy, so our synthesis and implementation both schematics are same, but in a case of a complex design where you have added an optimization strategies, you could clearly understand that there might be a differences in an implementation, right? So it becomes mandatory that we also verify that it is working correctly when we implement our design, right? So remember, whenever you complete a synthesis, we'll just go ahead and again perform post synthesis functional simulation. So this will verify whether our design, the synthesis design, is still working correctly, right? So we'll go ahead and click on that option. This will again open our waveform viewer, right? and now you could see we have an buff been added, okay, and A, B and Y, right? So we'll just be forcing an input, right click, force clock 120, okay, and the period that we'll be choosing for an A is 100 nanosecond, and for B we'll again be choosing a period of 300 nanosecond, right? We'll again be evaluating our all the stimulus for 1000 nanosecond. So let it just verify whether our design is working correct, right? So when we have 1 1, so output should be 1, that is happening over here. When 0 0, it should be 0. 1 0 should also give us 0. The only case that we need to verify is 0 1, right? So here also you could see our output is still 0, so it is still working correct, right? The next step after you verify the behavior in a post synthesis functional simulation, we'll just be going ahead and perform post implementation functional simulation. Okay, here also we'll be doing the same thing, force clock 120, 100 nanosecond, for B 300 nanosecond, right? And we'll just again hit on run for 1000 nanosecond, right? And here also you could see the same waveform, right? So our design is working perfect in both after synthesis as well as after implementation, right? Now we are ready to generate a bit stream. So bit stream is something that will be going on to an FPGA, right? We'll just hit on generate bit stream. Now since we already completed an implementation, this won't be taking much time. So our bit stream is completed. Now it's time that you connect your hardware to your personal computer, right? And we'll just hit on open hardware manager, right? So once you open an hardware manager, you get an option open target, right? So you'll just be clicking on open target and then auto connect. So this will automatically identify the board which is connected to your PC, okay? And once your board is identified, we will just go ahead and program our device, right? So you'll be finding we have a two option. One is a bitstream file, which is a bit file that we have generated. Other one is a debug file. So when we add an ILA, which is an integrated logic analyzer used for an hardware debugging, there you'll be finding an LTX file is added. Okay, since here we have not performed a debugging, so this is empty, right? So we'll just click on program FPGA, and then you could observe the state on an LED as you change the state of switches, right? So this completes an entire flow of an FPGA, right? So flow navigator is very, very helpful here. So first we have two ways of specifying a design. It may either be a text based source or it may either be a schematic based source, right? Once you complete your source, you proceed for a functional verification by performing a behavioral simulation. RTL analysis gives you the first view of an HDL code, so the typical system that you are designing, whether it is matching to the schematic that you have chosen, right? Then you have a synthesis. So synthesis transform your HDL code to something that our FPGA understand. Then you have an implementation. So before implementation, it is mandatory that you specify a constraint, okay? And then depending on the constraint, the specific side on an FPGA will be chosen where our logic will be placed. And finally, you have a program and debug where we will be generating a bit stream, connecting our FPGA board, and then downloading a bit file onto an FPGA. The last step will be to verify a behavior on a hardware itself, right?